In 2017, Chinese scientists achieved what seemed impossible. They managed to teleport a light particle, and not just by a few inches, but from Earth up to their space satellite, which is 310 miles away. Teleporting a photon might not sound impressive to you, you buzzkill, but it was a historic moment for quantum mechanics and space technology. Sure, we're not zapping people back and forth like in Star Trek yet, but it's the first step. The satellite, which is a celebrity now, is named Micius. It's equipped with special tech to receive and read the quantum state of the teleported particle. Micius is the first place in the universe with which our planet has a quantum link. The experiment had to be conducted in a super-controlled environment, in full peace and silence. So no wonder they decided to do it in Tibet. A ground station in Ngari is located over 2.5 miles above sea level, about half of Mount Everest's height. At such heights, the air is noticeably clear, and not even the tiniest dust particle can mess the teleportation up. This teleportation technology is based on extraordinarily complex theories, including ideas of Stephen Hawking. And the main trick here is that it's not traditional teleportation, not in a sense we're used to. Everything there works on a funky concept called quantum entanglement. Basically, it says that two particles, like photons in our example, can be linked together in such a way that if you change something about one, the other one changes instantly, no matter how far apart they are. Even if there's an entire universe between them, they'll still feel the changes in each other right away. And that's not the creepiest part. All electrons, photons, atoms have their own quantum state, which describes all the information about them, stuff like their properties, position, and energy. Scientists can read this information, getting to know the particle. And for some crazy, unexplainable reason, as soon as we learn information about one entangled particle, the other one becomes its copy. Imagine there's a brother and a sister who live in different towns, but when you get to know the brother, the sister suddenly becomes his twin. Weird analogy, but you get the idea. Nothing traveled between these particles. They didn't exchange any information with each other. They just know that we know. It's like they have a strange, invisible bond that nothing can break. This really unnerved Albert Einstein back in the day, since he believed that nothing can travel faster than the speed of light. But this communication happened faster. Einstein called this a spooky action at a distance. In any case, here's how the Chinese scientists pulled off their experiment. First, they entangled or linked some pairs of these photons at a lab on Earth. They kept one photon of each pair on the ground and transmitted the other one up to Micius using a high-precision optical system, and equipment on the satellite caught it. After that, they read info about both photons, the one on Earth and the one in space. And you guessed it, the ones in the space copied the information about their buddies right away. So, by reading info about a particle at spot A, we transfer its state to spot B through that invisible quantum link. Which means that actual, real-life teleportation is not about literally moving you from Earth to space, but about creating a full quantum copy of you somewhere else. Isn't that insane? That's quite horrifying, and opens up a lot of questions. Imagine you have a famous old ship. It's so cherished that over time, as parts of it wear out, each piece is replaced with a brand new one, an exact copy of the original. After many years, every single part and nail of the ship has been replaced by their identical copy. Now the fun question pops up, is this shiny ship still the one you had? Or is it something entirely new? That's a famous philosophical riddle called the Ship of Theseus. You can see how we can ask the same about people and photons. So let's take this Chinese technology and teleport you from Earth to Mars. Every part of you, every particle, is recreated perfectly on Mars based on the quantum information sent through space. Are you on Mars still you? That's a tricky one. Both versions would feel like the real you to themselves. Here are some possible options. Option 1. No, it's not you because we only transferred information about you, and not your literal physical atoms that you're made up of. The original ship was always the real one, because its particles never changed. On the other hand, okay, maybe the atoms are different, but this person literally thinks like you and remembers everything that you remember. From a quantum perspective, if you guys have the same quantum information, you are literally indistinguishable. So both ships are the real ones. And the final option is that it's not just about atoms or consciousness, but about your life experience. You're still in the lab talking to scientists while the other one is now enjoying the Martian sunset. No matter how similar you are, it's your history and life that makes you you. Phew, that was some crazy philosophical puzzle. But let's get back to reality. How can this teleportation change our lives? One of the coolest things will be the quantum internet that spans our entire planet. The internet is basically a superhighway where information zips back and forth like cars. But it still takes some time for light particles to travel from their servers to your phone or PC. Now imagine a world where all this data appears on your device instantly, and all computers work much, much faster than they do now. Plus, all communication would be super secure. After Chinese scientists made this discovery, things have been progressing crazy fast in the world of quantum mechanics. Just this year, scientists achieved another huge feat. They've managed to teleport quantum states with nearly 90% accuracy, even in noisy conditions. Remember how we said that Tibet was the perfect place for our experiment? That's because there's no greater enemy for quantum teleportation than noise. The entanglement is a very delicate thing, more fragile than houseplants. Literally anything from the outside can easily disturb and destroy it. Before, scientists tried their best to teleport stuff in noisy conditions. They designed special paths for the light to travel, and used some cool gadgets to help keep the light particles stable and not get all fuzzy and mixed up. But now, they went a step further. They made a cool machine that helps particles avoid the noise. Even though there are still disturbances around, like bumps and stuff, the magic machine still made sure that the connection between the photons stayed strong and the teleportation worked properly. So now this teleportation almost always works. Another cool experiment was conducted in Germany. They found a way to send quantum information through our regular internet, the ones you use to watch this video. Hooking the quantum internet up to the regular one is tricky because they work differently. Remember what we said about noise? It would be like trying to have a very delicate private chat in the middle of a noisy party without anyone else hearing it. All the regular internet noise usually breaks quantum information instantly, which is why usually it needed a quantum link, its own quiet road. But German scientists wanted to see if they could somehow send quantum information along with regular internet data down the same road. So they used this cool technique where they gave quantum and regular data a special rhythm so they don't bump into each other along the way, and that's how they managed to send quantum states through our regular optical fiber, the internet's main road. Nothing got mixed up and things are still super secure. Now we just need to find a way to make this work on very big distances, and the online world will be faster and safer. Quantum internet, we are all waiting for you. Maybe then I'll be able to watch YouTube normally when someone downloads stuff in the other room.